Anyway, so Friday, I had gone through the 3 types of transformations. The rigid transformations, where you keep the same size and shape. Reflections was one of them. Translations was another, and then we had rotations. So when we say translations, what does that mean? Like if you're translating a figure, what are you doing to the figure? Anyone remember what from Friday I had said what a translation was? Jocelyn? Yep, it's a shift, or you're moving it. So actually, another way they describe it is as a translation, or sometimes they're called a slide or a shift. So you're just moving it to a different place. You're not reflecting it, you're not turning it or rotating it at all. It's just being moved either up, down, left, or right, or a combination of the two. So a translation or a slide is a transformation that moves all points of a figure the same distance in the same direction. And then a translation can be thought of as a function that maps each point to its image along a vector called the translation vector. Which, have any of you, I'm not sure which science class they're in, but have any of you worked with vectors before? I think that might be more of a physics thing, which you guys are not in physics yet. Okay. So vectors, you might, depending on what science classes you take, or even if you eventually choose to take trig pre-calc, is not a required math class, but if you take that, then you'll study more with vectors in trig pre-calc, or like I said, I think they're in physics. So we'll talk a little bit about vectors. You'll see what they are. But a translation, again, is a function that maps each point to its image along a vector called the translation vector, such that each segment joining a point and its image has the same length as the vector. And this segment is also parallel to the vector. So, actually, let me just say this before I talk more about it. So a translation vector below, it shows distance and direction. And vectors are named with a symbol and a lowercase letter. So like vector V, for example, and then you see it's kind of like a little partial arrow written above it. So they show up here. If this was vector K, so you have the length of the vector, you'd actually take a ruler. You guys don't need rulers today, you'll see why. But you would take a ruler and you would measure the length of the vector. And then you also see the direction that it's going. So if this was point A, I would draw a line or a segment that is parallel to vector K from point A or through point A, and then I would measure the length of it, and that would give me the length and direction of that vector from A to my image now. This would be where A prime is using that vector. So that's why they have to have the same length and they have to be parallel. So here's an example. I'm not having you guys actually with rulers draw these in. I just wanted to give you the idea of a vector, and then we will do more with vectors in a coordinate plane and how to work with notation that way. But this says use the figure in the given translation vector, draw the translation of the figure along the transformation vector. So here's the vector. This would be vector P. And so if I wanted to translate this object, LMNO, that trapezoid, along vector P or using vector P, these dashed rays that are coming out of each vertex are parallel to vector P. So you would draw a parallel ray from each vertex. And then you'd actually have to measure this length and then make sure that these rays are all that same length. So these rays are all congruent to the length of vector P. And then that gives you your new point. So that gives you L prime, M prime, N prime, and O prime. And then you would just connect your new points to get your image. So that's what that means. Again, you are not actually having to measure and make sure that you draw them exactly parallel, but that's the meaning behind it. We are using vectors more in coordinate planes. And then we'll get into the component form of them. So how we're actually doing this, or more so doing this, the component form of a vector. So a vector in a coordinate plane can be written this way. So notice it's not really an ordered pair. It's similar, but you don't have parentheses. You have kind of like, not really arrows either, so I'm not sure how to describe them. But that grouping symbol, it's not a parenthesis on either side. But A is representing the horizontal change. So normally, like if you think of an ordered pair, your x coordinate, the x-axis is horizontal, so A is representing the change in your x value, that horizontal change. And then B is in place of the y coordinate, and y is a vertical axis or a vertical change. So this is the vertical change. And that's the change from the vector's tip to its tail. And so it shows here that segment CD is represented by this ordered pair, this component form of a vector. So the reason why, so starting from C and ending at D, to get from C to D, my horizontal change is I have to go to the right 2, and then I have to go down 4. I have to go right 2 and then down 4. So notice my component form, that's what the 2 represents. The positive 2 means my horizontal change was positive 2, so I went to the right 2. So if I went left, it'd be negative. And then the negative 4, that's the vertical change. So since it's negative, you're going down 4. If it was positive, you would go up. So that's what that's representing. And then this is obviously the shortest distance there. So then if you had this as your component form, so if you're in place of your A was 0, there was no change there, and you just had B, that would just be a vertical change. There'd be no horizontal change, only a vertical change. So that would just move the figure either up or down. And then just the opposite of that, if you had A and then 0, the A is your horizontal change. The 0 means there is no vertical change. So it'd be just moving right or left. And then which way depends on your actual sign. Is it positive or negative for which way you move? And then we also have, so here's a vector AB. So horizontal change is A, vertical change is B. The XY here, this would be from your pre-image. So that would be your original coordinate. This is then a way to find your new coordinate if you wanted to find the coordinate prior to actually plotting it on a graph. So you would take, since A is the horizontal change, the A value is added to your X coordinate. And then since B is your vertical change, the B value gets added to your Y coordinate. So I wouldn't say this is something you need to memorize, just more so something you need to understand how you're getting from your pre-image coordinate to this would be the coordinate of your image. And they do show here, so I just want to show this to you. I want to come up with the vector. So from P to P prime, based on the ordered pair it gives you for P, the ordered pair it gives you for P prime, what would the horizontal change in our vector be? Anybody know getting from P to P prime? Oh, 7, yeah, 7 and then 4. So you are going, since you have the plus 7 here, that tells me that I moved to the right 7. And then since the y coordinate is then 3 plus 4, the plus 4 is the vertical change. So then I went up 4. So that vector would have been positive 7, positive 4. Just to understand that notation a little bit better. Okay, so now we'll actually get to using this. So it says graph each figure and its image along the given vector. And then like we did on Friday, I know it doesn't say in the directions, but you are given the coordinates of your pre-image. I am going to write down the coordinates of the image, so the coordinates you get from actually translating the object. So I have E is -7, -1. And then also, just because I noticed on some of your assignments, you're not labeling your original pre-image and then your image. So just know, like on a quiz, on a test, if you have 2 figures drawn and they're not labeled, so I can't tell which one is your pre-image and which one is your image, you will lose points for that. So make sure you're labeling everything accurately. So as I plot a point, I just label it right away. This is E. And then -4 is F. -3, -1 is G. And then we have our translation vector there. So I have a triangle. And then based on this translation vector, what change does the 2 represent? You're going to the right 2, so it's horizontal change first, so right 2. And then what does the 5 mean? Up 5. That's a vertical change. It's positive, so it'd be going up. So you have a couple options. You could use this and find your new coordinates of your image and then plot them. But since you're graphing it anyway, this is what I did, or what I would do as I'm working through it. I would just start at E, and I say, okay, from E, I go to the right 2, and then I go up 5. And then I plot my new point, that's E prime. And then I can write down what that coordinate is. So E prime would be at what ordered pair? -5, 4. Okay, and then I can do the same for the other 2. So then F, if I go to the right 2 and up 5, this is F prime. That ends up being at -2, 1. And then G is at -1, 4. That's G prime. And you are just translating the object, so it shouldn't appear to be like oriented a different way, like it shouldn't look like it's rotated or reflected. It should look the exact same, just in a different location. Any questions on that? Okay, some of you I know might be working ahead right now on B. I was going to have you do B on your own or in your groups, and then we'll talk about C, but you can take a look at it if you're waiting. But do B first. Okay, looks like we're okay. We all had the right translation at least. So yes, make sure, and some of you are writing in pencil. I was glancing to see that it was drawn in the right place, but make sure you are labeling JKLM, and then you have your primes. So you have it clearly labeled, which is the pre-image, which is the image. I listed what those new ordered pairs were. Any questions on that? Some of you I know are also answered C, so here make sure you have it right. So C says, in one part of a marching band's performance, a line of trumpet players starts at position 1, which is here, marches to position 2, and then to position 3. Each unit on the graph represents one step. And you can see, like, this is would be like your x-axis, and then this would be your y-axis. It is labeled, but it can be a little confusing to look at. It says describe the translation from position 1 to position 2, and then it says in function notation. So I'll show you what that means, because that's different than a vector. So this is written as a vector here. In function notation would be a little different. I'll show you what that means, or what they're looking for when they say that. So what I would do for this one in position 1, or what I did is I picked just a point from one of them that was in position 1. So I actually went with this one just because it was easy to pick out the coordinates, because those coordinates, my x coordinate is 8, and then my y coordinate would be 2. And then I'm only looking from position 1 to position 2. I'm not looking from position 1 to 3. So I'm only looking in that first movement to 2. So I followed that person that would be in that spot. That would be this point here. So now their new point, the x coordinate is -4. The y coordinate is still 2. So how did everybody in position 1, what was the movement from position 1 to position 2? What was the translation? It was what? Well, you are right. The vertical change is 0. The horizontal change is more than 6, though. The horizontal change is 12. Yep, to get from the x coordinate of 8 to the x coordinate of -4. So you have to be careful if you're counting the actual grid markings. The scale is by 2. So I understand if you got 6, how you got that. But you are going 12 to the left. So left 12 is the movement from position 1 to position 2. So then if you are writing it as a vector, because I know some of you already had an answer for this and had a vector written. So as a vector, it would be -12 is your horizontal change, 0 is your vertical change. But this says in function notation, so this is what they're looking for. They're saying if you start at a coordinate xy, what's a formula to come up with your new coordinate? So they, with function notation, they're using this coordinate form instead of the vector form. So they're saying you add the horizontal change to your x coordinate, you add the vertical change to your y coordinate. So this would be, since my horizontal change is -12, my new coordinate would be my original x coordinate and then -12, comma, my new y coordinate I'm not changing, so I'm really taking y plus 0. And that's the form that they're looking for when they say that. And then you could double check for the 2 points we plotted just to make sure. If I take 8 and I subtract 12, I do get -4. If I take 2 plus 0, I do get 2. So you could double check it that way. Any questions on that? Okay. Those are translations.